So this is the cooler that is used to be the insulation for the bomb calorimeter. So you can see the bomb next to it, and it's underneath it is a stirring hot plate we're going to use to stir the water bath inside the calorimeter. So what I'm going to do is come up close to this so you can see inside the calorimeter. So what you'll see is there's some insulation here. There's a bucket that holds the water, and down inside the bucket you will see a piece of plastic and then a stir bar on a little piece of glass. And I don't know if you can see it stirring now. What's going to happen, and I'll take another picture of it after we put the bomb in, is what you do is you set the bomb in carefully so that it doesn't hit the stirrer. And then we need to add 2 liters of deionized water. We do that by filling 2 aliquots of 1,000 milliliter, 1 liter volumetric flask. And we use that so that we really know how much water we have. We use deionized water because we're going to make electrical connections underwater, so we've got to make sure that we do not have any ions in the water, or it will conduct electricity, and then we won't be able to light our fuse. So you'll notice I'm using deionized water from a container that's been sitting on the bench, the idea being that it would be room temperature. So we start out with the inside of the calorimeter close to the temperature of the room, so there's no difference. It isn't going to fluctuate as much. And we use a squeeze bottle to top it off. Just go ahead and pour it in. It's a good idea to try to be careful so that you don't knock the stir bar off of its little plate. So once we get the water in, we will check the stir bar. So if it fills properly, there's some little black marks in the inner container that roughly is where it goes to. But the important thing you'll see is that it covers the bomb completely, so that all the heat generated in the bomb ends up in the water. If your bomb is leaking, you might see bubbling, but it shouldn't be leaking. So once everything looks pretty stable, you can take the stir bar and try to get it up as high as you can. Usually it's between 600 and 800 RPMs. Is about as high as you can get it, but sometimes if you're lucky you can get it more. The higher your stirring rate, the better your results will be because you're better mixing. Whoops. So this one about 800 is where it started causing problems. So you'll have to actually look in there. So now we're almost ready to do the calorimetry, but we have to get some connections. We have to get the electrical connections, and it doesn't matter which of the two leads hook to which, but you just stick them in. Put the lid on. You'll notice that the box that we use to light it off isn't plugged in yet. We won't plug it in until right before we're ready to do that, ready to light the fuse off. And we can lock this down. And then there's another hole here where we'll put the thermometer in, this temperature probe. It'll just be hooked to a vernier box into the computer. We'll use that to monitor it. When you're all ready, you'll plug in this lead here, the prop to the plug. Now it's powered. Once everything's all stable, your temperature, you've monitored temperature for a couple of minutes and it's stable, you just push this button. And you don't have to push it till the light comes on. This light will glow, and then you're done. Once it comes on, that means the fuse has been melted or burned away and there's no connection. And now you just monitor the temperature with Logger Pro until the temperature stabilizes again. When you take it all apart, let the gas out of the bomb carefully. So you can take off the connections. You take the bomb out. You can either lift it out by hand, or we do have a little thing that'll go into some holes on the side of the bomb. But sometimes it's hard to actually get it to hook up. So I usually just reach in with my hands and lift the darn thing out. And bring as much of the water as you can back in so you don't make a terrible mess on the bench. Now the important thing to remember is you can't open things up until you release the pressure. I usually also dry off the top so it's some water spraying everywhere. So once you've released the pressure, it'll be possible to unscrew this. If you don't release it, it's usually not possible to unthread. The hard part is often still getting it apart. You have to be a little bit patient. It does jam. So you often have to sit here and wiggle it a little bit to get it to come up. Once it starts to come up, it'll be pretty easy. And if you actually lid it off, the fuse will be gone, your material will be all burned up, and you'll look at the inside to make sure there isn't any soot. If there's lots of soot, you didn't have a good run.